All right, so the idea is that there is one chair empty over there, and one chair remains empty at any given point in time. This is to encourage people from the audience to come up and take that chair whenever they feel they have something to contribute. So it's not a one-way thing. Of course, we've seeded the panel with the speakers from today or over the conference, on the conference speakers. And the idea is that when you folks are going to ask questions that you think were not answered today, and then once that is done, then when you ask a question, it depends. You can Tony, if you don't mind, just we'll rotate the speakers. Yeah. We will get you up shortly. So when you ask a question, you could specifically ask a question to one of the speakers up there, or you could ask a generic question and you could say, I would like every speaker's opinion, or I would like anybody's opinion. Like, up to you when you ask a question. All right? So simple rules: you ask a question, the panelists will answer. If it's directed to a specific person, they will answer it. If not, anybody will pick up and answer. If you are in the audience and you feel you have something to contribute to this, then you come up, take the empty chair, and you get a chance to contribute. When someone comes up and takes the chair, one of you will have to leave the panel. So that ensures that there is an open chair at any given point in time. Yeah? Simple? So who wants to inaugurate? Do we want to introduce the speakers quickly? Maybe? Not everyone was in every talk. So.
All right. My name is Saurabh. I write a lot of Haskell at Vacation Labs, my company. We have about close to 100,000 lines of Haskell code in production. So yeah, you can ask me anything about Haskell and how it compares to Ruby, because the other 100,000 or 200,000 lines are in Ruby on Rails.
My name is Andrea, and I work with Elixir. I'm a member of the Elixir core team, and yeah, mostly work with Elixir. So if you have Elixir or Erlang questions, I can try to answer.
My name is Bruce. I work with a tiny startup called Groxio. I am a language expert. I also work with Elixir.
My name's Edward Komet. I do a lot of work in the Haskell ecosystem. I think I personally maintain something like 2.5 million lines of Haskell. Which is somewhat absurd at this point. I'm trying to figure out ways that I can replace that with something like 400,000 lines worth of Coda. We'll see if that happens at some point. That's not the majority of the 2.5 million lines worth of Haskell, although it does contribute.
My name is Aaron Su. I'm one of the APLers here, and I guess I'm responsible for the Codefunds compiler.
Numbers of lines of code. I think you're going to have us all beat in the right direction.
So I've got a GPU-hosted data parallel compiler for an untyped, functionally oriented language that is written in 17 lines of APL. It's 948 nodes, 74 unique names, and 1,000 tokens, something like that. Yeah, 4.5 million lines of GitHub edits.
I'm Morten Kronberg. I'm the CTO of Dialog. We would say the leading vendor of APL systems in the world. So my job is to think about the direction that APL should be taking in the future.
I'm Alexander Granin. I'm a Haskell developer, and my mission to make Haskell more adopted by mainstream and industry.
Hi, I'm Anupam Jain. I work for S&P Global, the very small FP team within S&P Global. I mostly do web development with Haskell and PureScript.
I'm sorry, you have to clean up my messes.
Ed Komet used to work for that team, and now he left just before I joined. Yeah, so but we have great help there.
say functional programming. So if I said it when I was walking down the street, I'd look for the police and the handcuffs. And I believe that we've made some progress since then, but I've come up against it again recently in my work. And I'm wondering if anyone has any comments or techniques to continue dealing with what I call denialism. Comments like functional programming is not good or anything without even knowing what it means. How do you deal with this, and how can we bring it further into the mainstream so that we can comfortably talk about it and take advantage of it in our work?
So 15 years ago, my experience was mostly not that functional programming is banned, but that we don't know what it is. And even now, I would say it's something somewhat similar. When I still get comments that when I say Haskell, people say, "Oh, Pascal." But so I think the step here is educating people, and conferences like these really help with that. But I don't think I've had a lot of resistance with people willing to listen. It's just that resistance to adopting it in their work, which is understandable. So yeah, so continuing on the path that we are going on, I think we'll get there. The day of FP will come. So.
Okay, considering functional programming is about Haskell nowadays, mostly. Yeah, I can answer the question how we can make our best functional programming language more popular in the mainstream. It seems we have several problems to solve for this. The first problem is that okay, Haskell is quite different in sense of its semantics, its concepts, and its code structure. Still, it's not really different in the design space. If some business wants to build applications, it doesn't bother about functors, applicatives, type level magic, type families. It needs to create real value to get its job done. In this sense, a real value comes from the possibility to change your code according to fastly, quickly changing requirements. And this means we should not play with our language, and we should not play with our cool concepts, but we rather need to focus on the creating this value. We probably need to understand that Haskell, while it's a very powerful language, it should be treated as other languages in the design space. Like, you need to structure your code, you need to separate concerns, you need to test your applications. This only can attract some attention from the mainstream.
I'll do one more. So I think when Naresh did the sort of opening comments about this, it was sort of the 2 feet principle of, vote with your feet. There's something to be said about the fact that, the blockchain has acted as sort of the Haskell Full Employment Act. And if you really are willing if you just aren't happy where you are and just need a job and are willing to work pretty much anywhere involving a blockchain, you can probably do something that may or may not be meaningful to your to your personal ethics. But one can get up and leave pretty easily with that sort of escape valve on hand.
So I think that if you're selling features, if you're talking about features that you've already lost, what we need to be selling for functional programming is success. So it's all about business value. It always has been, and so I came off about a period of doing about 10 years of language adoption talks, and every single one of them was a different angle on the same discussion. Where does the business value come from? And where do the other languages have limits?
So I think we need to sort of, again, it goes about awareness at 2 levels. One is at the very top of the end, which is talk about and celebrate successes, right? I have a hypothesis. Erlang people can correct me if this is wrong. the acquisition of WhatsApp did a lot to sort of create the buzz around Erlang, right? So we need to talk about where these were, the programming language itself was critical, or you know, was one of the reasons behind a business's success, because that gets covered and talked about a lot more. That is at the top end. At the entry level, specifically for Haskell, we probably need to create educational material to make the journey to learning Haskell easier. Because once you've learned about a success and you want to sort of get into FP, it shouldn't be that uphill a task. We need to make that thing easier as well to get broader adoption.
Okay, sorry. This is a huge passion and big topic of mine, so forgive rant on. Every single one of okay, the short TLDR, stop playing a religious game, start actually doing real science. So here's the problem, is everybody here has talked about, basically the solution is to deliver more miracles and preach those miracles in a constantly religious battle between who's got the best programming language. That's the state of programming language design right now. We're great implementers, we're terrible designers because we have zero practical experience with how to do good design and what that means, because it's a human social science, it's not a mathematical science in the way that we would like it. So we ignore it and we turn it into a religion, and then we fight back and forth about what's best on religious arguments with faith-based reasoning with no actual evidence to back up any of our claims except for the miracles that we perform, right? Or the magic shows we perform. And that's not a sustainable model for actually explaining why something is of value. Your business value is essentially, look at this miracle, maybe we can replicate this miracle. If you go with one of us apostles, we'll help establish your church, right? That's what we're doing. It's this exact same model. What we need to do is start recognizing that HCI design, HCID, those guys who do all that work on developing the cognitive science and applying it into things like Facebook and all of these apps, have something that's really valuable to the programming language design community. And we should start doing large-scale usability research and design using those techniques and formulating patterns and ways of addressing that inside of the programming language design space. Because if we do that, we then have the research to say, this actually is useful, and this is why it's useful in this space, and this is how people engage with that code, this programming language, this is how they use it, this is how it affects how they think. And now we can have a conversation between two languages and say, oh, should I use semicolons, should I not? Should I use this types, should I use not this types? All of those now become useful decisions because we have data to back them up, and we're not just arguing based on how we feel or who influenced us the most by showing us the most compassion in our journey towards enlightenment. Thanks. Sorry.
All good.
Sorry.
I'm not following that up.
All right, so let's move to the next question, trying to keep the energy high. Questions?
So, coming from the perspective of a user of things like software and mobile phones and computers or whatever, it's a pet peeve of mine that I need more resources to do the same thing year after year after year. Okay, and like as a person who has come from a non-programming background, it is very odd to me that this is an acceptable state of affairs. Like, why is it acceptable to to have so much waste around? We seem to be producing more interesting and powerful constructs, but somehow we seem to be consuming more and more resources. What is the rationale for this? Like, why do you think this is the state of the affair of the world right now?
As hardware gets faster, software gets slower.
Yeah, the whole system gets slow. Like, and systems of systems get slower after they perform worse or become more expensive. So.
I mean, I can say one small piece about this, which is the sort of almost apology for this current state of affairs, which is, you know, in many ways we ask a lot more of our tools and our environments than we used to. Like, once you have this headroom to do things, we ask our compiler to stay resident, so it's giving us information about the symbols that the compiler was using, so that you can actually have all the tooling inside of your VI or Emacs or Visual Studio Code. So we ask a lot more of our tools, and that's one component of the thing. I mean, there's folks who like do have this sort of microscopic focus. The Rust community comes to mind, like religiously avoiding having a runtime system. I will say Haskell is definitely not one of them, and I definitely pass this to somebody else who has more interesting things to say than I.
I think I said most of my opinion about this yesterday, so I don't feel I need to reiterate that much, but I think basically we have the wrong abstractions. APL.
One thing that I would like to add to that is that a lot of the layers that we built upon software have to do with the fact that people who are working with that layer don't understand how it works. So they build more and more abstractions on top of it. Then someone uses that abstraction and doesn't know anything about the layers below. So it's more about understanding your system, and the more we understand the system, the less layers we're going to build around it. So we need to work more towards that, educating resources to help people understand what they're building, right? So.
Yeah, functional programming started being popular in the industry not that far, not that so far back to the decades, maybe 10 years, maybe not more, yeah, right? I mean intensively. So it seems not our fault that software is so slow.
Oh, sorry.
So I think that one of the things that's happening is that the level of abstraction is coming up on the hardware layer, and I think it needs to. I had the opportunity to teach a team of mentees in Chattanooga, Tennessee, from experience from non-programmers to people that had a couple of years of coding experience, a project, and the project was to build a photo booth. The photo booth was on, Raspberry Pi, and then a couple of layers on top of that. And it was pretty gratifying because we were able to do that on a much higher level language, and we had the tools and the infrastructure to burn the burn the cards over the internet. We had full networking on the cards, so I don't think that that we're comparing apples to oranges here. I think that the level of abstractions are getting higher, and I think they really need to.
What was this great language you're talking about?
That's on Elixir with nerfs.
I'm just kidding. Yeah, I know.
So there's another aspect of this, which is there's a cultural and an education component that I think we could do well to maybe improve a little bit, because across the board computer scientists are terrible at educating, which leads to poor competency, which leads to a culture that has to justify that poor competency, which contributes highly to a lack of high performance and of the ability to deal with those extra value add things that maybe don't appear important but are the long-term decisions we need to be making. So if we sort of fix some of those issues, we can create the space to work with a more long-term vision, I think.
Being the person in the middle, I'll hold this.
I might be wrong, but the most slow software we have now is like browsers, like IDEs maybe, and GUI applications, and maybe Rust can give more sense here. For example, in browsers, yeah, we can do that way.
Yeah, let's get the mic on.
Yeah.
seat's yours. Okay, again, this is again coming from a user perspective and somebody who's interested in just looking at the world from that perspective. Uh, it fascinates me that we are able to we are able to run a system that sends 23 watts of power our way, and we're able to sense a billionth of a watt, and that system has been running for like 40 years plus. The Voyager probes 1 and 2, both of which have gone interstellar now, and I mean, it's very hard to follow that act. Uh, uh, it's really hard to follow that act. Um, and even having these examples out there, like real life examples you can see today. There's like this, what do you call that? Like disembodied kind of experience. Like there's a quote from The Wire for fans of that TV series, like world going one way, people going the other. Yo, okay, so it kind of feels like that. So I mean, that's what I wanted to say. You know.
Sorry. And rightly so, there are flaws, but languages like specifically Java and JavaScript, they've exploded in popularity and usage, and PHP. So specifically, they are clearly doing something right. You may not like it as functional programmers, but clearly the ecosystem is doing something very, very right. What are these things that we can take away? One thing that I've experienced is that IDs are a dream to use. IntelliJ is a very, very powerful tool that I have at my fingertips. So like pay a little bit of money for the ultimate hit. But what are some of these things that we can take away from the much maligned languages and ecosystems out there? Like JavaScript that somebody was rapping on, not.
So I think that one of the things that's happening is inertia. I have a couple of times through a college called Mississippi State University, and that's not a very big technical college in the United States. When I was coming through, we were one of the first schools accredited in the South, and the school was dedicated to teaching undergrad studies and not investing so much in research and hardware. And the school did very well. More recently, the school has been investing a lot in the Java infrastructure and the Java professors and the Java curriculum and the certifications. And there's not much room for the curriculum to go. And so there's not much room for the curriculum to grow. So I think that we have to overcome a lot of inertia in academia, really, and in corporations also, for things to move.
So I've worked with JavaScript, Java, and PHP earlier. I can give some insight into what made it easier for me, because I did dabble with Haskell at that time as well. It's when you have a problem to solve, that's when you look for a solution, right? So when you have a simple problem, you expect the solution to be simple. A lot of these languages that we work with now, we realize that they scale well, they have nice abstractions, but are they really easy to get started with, right? And there's a lot of boilerplate, and there's a lot of concepts that you need to understand before you even get started, right? I think we need to work more on that. And then tooling is a really big factor that basically contributes to the same thing. You cannot get started, a person new to the language or framework cannot get started if you don't have good tooling. If you don't have an IDE, you have a research project. That's what I believe. So so Haskell is still a research project in that sense. But whereas, and it can be done because PureScript has much better tooling. It's like a pet peeve with me because over the past year or so, I've started getting into PureScript, and the ID situation is very nice there. So PureScript is much easier to get started with. And the same with JavaScript. The JavaScript with, you have sources available right in the browser. You have fantastic debugging tools right in the browser. You're using the application, you can see all the libraries that it uses, right? Those are the things that we need before things will, before people will adopt Haskell. So because PureScript compiles to JavaScript, it has some of those advantages because you can jump into PureScript code and jump into JavaScript code beyond that. But I think those are very important, much more important than we give it credit.
So, not a surprise that I'm opinionated, but I want to reiterate that education question, because if you actually look at what happens with a lot of these things, you can see a correlation between the time it takes for a university graduate student or a set of them to begin to enter into the workplace and then get senior enough to affect decisions in that organization and programming languages and how that changes, right? And so you can begin to see the effect of object-oriented programming in the 80s and the 90s finally leading into something. And then you can see the same thing in functional programming during the 90s, getting into the 2000s, right? And I go back to that experience, right? So you've got the education thing. So if you don't equip the students coming out of these things to think with a certain model, the experience of engaging with that new language is going to be significantly worse, right? So they have to, the barrier to entry on functional programming, if you have never seen it in your university, is really high. But if you learned functional programming as an undergrad, suddenly maybe you think it's useless or not, but then suddenly it shows up again at some point and it's much easier to adapt to at that point. So there's a big usability question, and that usability goes right into tooling because the tooling matters as well. And when you put the whole thing together, what's the experience that they have? And this is a place where I think somebody the other day mentioned the correlation. Was it you that talked about correlation and pursuing an end goal and something happens to be correlated with that end goal, and so we hyper-optimize for that correlated thing, but it ends up leading us in the wrong direction? So this is I think this is a really insightful thing because we do this a lot in our programming languages communities. And if we can shrink this down to a simpler problem, keyboards. So keyboard layouts, right? I'm a geek about keyboard layouts. And I'm a really big geek about keyboard layouts because I can type really fast on all the 4 major keyboard layouts in English: Dvorak, QWERTY, Colmac, and Workman. And I spent years studying the effects of each of those layouts. And each of those layouts purports to be better than QWERTY. And there's this classic example that was mistaught in business school saying, oh, well, Dvorak should have won based on how much better it was, but it lost because even though it was an inferior solution. The problem is that's one of those bad examples because actually QWERTY is not bad when you think about what really matters to somebody who needs to type at a high performance level. It's actually one of the fastest keyboards. You can type really, really fast on QWERTY compared to the other systems. It's just that those other keyboards are hyper optimized for things that people think are correlated with performance and efficiency. So Dvorak does the optimizations of the key. Colmac optimizes certain finger triplets. Workman optimizes for a columnar layout. But when you actually get down to high performance, so I say above 120 words per minute on each layout, you start to see a pattern of which one flows at the high levels. And it comes out, oh, QWERTY is actually just fine. And I think a similar thing happens in our programming languages, is we optimize for this experience that we think is correlated with the end result that we want, and it's really not.
I just want to make a very small point to the very start of your comments, which is that I think just about 5 or 6 years ago, working with the ACM, there was just so like if you look at the standard like computer science curriculum, ACM advises universities about what that should be, and functional programming wasn't even on the syllabus of what should go into a computer science education as of 5 years ago. So we just recently got to the point where like it's even being included in the recommendations from the ACM as to what should be taught. So there's some hope, using your kind of timelines, that if we move forward another 10 years, then we'll be able to see better impact from it. But it's just now coming into the computer science curriculums.
These are like 20-year cycles we're talking about.
Yes.
I'd like to report points that both you made. I feel like, again, coming from a student and user perspective, what doesn't get taught doesn't get popular. So to extend the keyboard metaphor, like the fastest typists in the world use corded keyboards. Okay, they use cording, and they go up to like 300 words per minute many times. And but that's never taught. Like regular typing, QWERTY keyboard. I mean, I feel like uh, learning to touch type should be like a basic skill taught in computer science school, but it almost, like, at least in India, it almost never gets taught. And that removes accessibility to a lot of things. Like you cannot be productive on the command line. You cannot be productive in your plain text editor. It's really hard to get any of those things done. Like that is a entry level skill which opens up doors to many other, many other tools and utilities that are not becoming popular for that reason. So it's like, I think I'd like to refer that.
Yeah, it seems we are mostly talking about technical aspect of this educational reason, educational process. Still, I want to make a point that in 18th we had a situation when OP occurred, and it was equal to the phrase your code quality is how much OP you have. In this sense, the industry decided to teach other people to OP because of this. Not like separate people, but the industry as a whole. And maybe we can have a similar situation with functional programming when education facilities like universities or maybe schools will hear that how much FP you have in current code, this is your quality of the code. So whenever you have a bigger FP code base, then maybe you have more quality and less OOP, like something like that.
I'll just take the level of abstraction down a bit. Going back to the question was like, what are languages like PHP and JavaScript doing good? So I'll take the example of PHP. So a lot of us in this room have probably picked up PHP on their own, right? So the good thing about PHP is the beginner onboarding story, right? It's just so dead simple, coupled with the deployment story. I mean, once you've got something working and you want to put it out into the world, PHP has got like nothing beats the deployment story of PHP. Get an FTP, transfer some files onto a shared hosting, and bam, your whatever concept that you've worked on is out there in the world. That's fine. That's yeah. But at least you've got your you've got started, right? So I mean that beginner onboarding. Like to give just one small example, why is PHP so popular? Beginner onboarding and the deployment story, right? So what it is primarily used for, either it was by design or by accident, but it's absolutely well optimized for that.
Okay, so I mean, this is really a question more than a comment. So APL is coming into this functional space sort of from diagonally from the side. We have a lot in common with functional programming, but one of the things that's really important to me in my daily life as an APL programmer is that APL is a multi-paradigm. So I can do imperative, I can do OO, I can do functional programming depending on the requirements of the particular application that I'm writing. So often a lot of my computational code will be in a very functional style, but then I'll be writing GUI in an OO style and so on. And to me, that feels very productive. I'm just wondering what people think about the importance of being multi-paradigm rather than purely functional.
I would say very briefly that I consider Haskell to be a perfectly cromulent imperative language. Yeah, I write a lot of imperative code. If you look at, I was talking about Guanxi, this logic programming framework thing that I have here, right? Behind the scenes, that's all mutable references and like very imperative style flow, like bolted in like the sort of functional paradigm. Yeah, go ahead.
Yeah, I mean, do you have a way to do that that makes you feel elegant, or do you feel dirty when you do that?
I feel no more dirty than if I were to have to go off and write it in Kotlin or Java or something like that. Like I at least get to I at least get to keep the rest of my tooling in my ecosystem.
Right, but I mean, some applications just, do this, do that, do the other thing. You shouldn't feel dirty.
I would OpenGL in Haskell if I have to.
Anybody else?
I just want to go back to the earlier comments that you made about bringing this back into. No, it's a question. So yeah, I think some of you were hinting that we should get some of these concepts into the college, into the universities, so people can learn them, and then maybe over the next 10 years or 15 years or whatever the cycle that influence. But if you were today in a college, or in a university, your goal would be to get placed, right? That's the highest priority. And when you think from that lens, you would look at what is the industry dominated by, and you would obviously see these big mainstream languages that are dominating. So wouldn't you optimize for that rather than saying, oh, I think there's this cool thing that I should optimize for, which hopefully in 15 years maybe will get me to something.
Well, I think right now, if you were to come into industry today, Java has picked up lambdas, right? We've gotten to the point where there's a little smattering of functional programming that everybody feels the need to incur in their language design, just to feel hip and trendy enough or something, or relevant enough to this current, like the current zeitgeist or something like that. So you're going to see it, like getting a little bit of it during your education and then seeing it in industry as sort of a gateway drug is already there. So I don't think, I mean, whether you like completely decide to wear their hair shirt and write Haskell all the time is a completely different thing. But I think like everybody I run into at this point in time knows what a lambda is and has gotten the idea of like mapping over a structure or like iterating and doing for eaches and stuff like that in a fairly object functional mixed style. So at least we've made those inroads.
So also, having been just deeply associated or working with the university in Indiana for a while, and I did a lot of education work there, and this question of what we should be teaching is a big thing. And the reality is that if you focus on, and IU has tried both approaches, the high theory approach and the get them a job approach. And the reality is that the universities are not agile enough to be able to get somebody placed in a job by predicting what they're going to need as skills. That it doesn't work, and the kids who come out resent the university for teaching them old skills that are useless. So the problem that we have with computer science right now is it's too big. There are too many things to learn that you cannot learn them reasonably in the amount of time given with the typical student that you're going to see. So the problem is that you've got to pick and choose what you're going to teach. And if you focus on teaching Java or these particular language skills or these particular things, you will never actually be able to place the students well. They will always have a bad record, and your university is going to get a bad reputation. The only real hope is to elevate the students' mindset about how they're engaging with the computer science field and teach them an engagement methodology with technology rather than teaching them a specific grounded skill. And that's all the time you have in an undergraduate curriculum in the US to do. And so what you do is you teach them all the things necessary to, as rapidly as possible, adapt to whatever position they can. And then arrange for good relationships with the local industry so that you have a reputation where you're giving the best students out, and then get them hired through those things. And you have to teach them programming languages to do that, and they will have those skills in certain programming languages, but they will not think of themselves as an identity of, I know Java, I know this. You have to stop making people think that's their identity until they've spent time in industry and actually know what's going on, because they need another like 6 years to actually figure out the landscape.
Yeah, a couple of things. The first, I'd like to make a comment on the the C++ idea. So this pattern of kind of sprinkling other paradigms with the next paradigm is not a new one. I mean, we had that with C++, we had that with Ada for OOP, and nobody really wrote C++ object-oriented code with the first iteration of C++, right? So it was more of a C++ minus, right? So, but this is already happening again. So with Python and with Ruby and with Kotlin, all the languages we're seeing not just the lambdas, but also the things like the folds. And so I think that this is happening. We're already seeing the wave of functional programming adoption. And I think that this time the wave is not necessarily going to be driven by the universities. I think that like the last time, Java wasn't adopted because of a wave in the university. Java was adopted because it solved a deployment problem. Because when it was time to deploy these super sophisticated client server applications that were coming forward, it was too much. And so we deployed to the browser, and the browser actually solved the deployment. That's what's happening now. It's the multi-core, it's the concurrency. So as we go from 16 and 32 cores forward, it's too much to balance in a single programmer's head, and that's what's going to drive things. And universities will catch up or they won't, right? And there will be an alternative.
Well, there are a lot of good alternatives already. Yeah. So I agree that universities are losing their immediate impact. I think they still have a powerful long-term impact, but there's a big movement for independent education in the tech field, and I think that's a really healthy thing right now. Much to the chagrin of the universities, but they need a good kick.
So with respect to universities, I agree with Aaron's point that you need to focus on concepts rather than giving the students an identity that you're a Java programmer or C programmer. Just today, I saw a cartoon in online somewhere that a student is sitting in a state machine class, and he's like, "What is this? I just want to write games," right? So I think what's missing is being able to give them a connection to a real-world application that they will actually be using. So with Haskell, you ask someone, okay, I don't know what functional programming is, I don't know what Haskell is, what is it good for? And you say, it's a general purpose programming language, right? That doesn't help, right? You need to pick blockchain, yeah. So you need to have something grounding, the person that, okay, this is what you can use it for. And that's when the interest will really come. So.
It's not worth getting out of bed otherwise. I'm staying in bed with it if I don't have a type system. There's no point.
So any anecdotes where you were actually, if you were in an untyped language, it would have been much easier, even if you factor in
that way. You wanted anecdotes. My anecdotes run my anecdotes run the wrong way. I'm sorry.
You want an anecdote in favor of the untyped.
So I was privy to a conversation that I really wasn't supposed to be. I was kind of a fly on the wall when a man named David Turner, who is the creator of a language called Miranda, walked up and talked to Joe Armstrong at a party in London. And it was the most fascinating conversation that I think that I've ever heard. So it turns out that David didn't know Joe very well, and he said, "Pardon, but I wanted to talk to you to kind of tip my cap to you for the reliability that Erlang has been able to achieve. I never thought that would happen from an untyped language," right? And so the philosophical discussion that those two men had on two ways to accomplish the same goal and the ways that they thought about those problems was really illuminating to me.
So I think I'm going to take the other side of this. For me, the reason why I work with type systems, you have this very polemic argument of, are type systems worth it? I could not do what I do without type systems. Now, there are folks who can live in languages like Erlang, and I've written my share, or in Clojure. And Clojure works really well as long as all of your problems look like lists and maps. But like, I write a lot of code that I'm not going to get right the first time, and I'm going to refactor and tear apart my APIs. And I have a lot of users. And if I'm doing this in a language like Python, what happens is the only way that I can ever migrate my users is to write an entire new library. I get the library wrong the first time. But if I ever remove a keyword argument from something in NumPy, everybody breaks in production, right? If I break an API in Haskell, I at worst break somebody at compile time. I can make fairly large refactorings of rather important to the Haskell ecosystem code bases, and the entire community basically adapts within 2 weeks. And I do not have that experience. Like, if we look at the JavaScript ecosystem, one of the problems with the JavaScript ecosystem is that they have to come up with a new UI framework every 6 months. It's because it's the only way to learn the life lessons from the past ones. Right. Okay? And so I can write a library, and I can still be maintaining it 7 years from now. And I can only really do that because I have the type systems breaking people at compile time.
So I'm going to actually come down a little bit in the middle on this one. In that, so I've done a lot of scheme programming, and I actually think I became more typed in APL. So my joke is that APL is a great type system that doesn't have to, that automatically gives you your terms. And the reason I say this is that the effect that you get from working with the types, the value that you get of working with the types, I feel that I achieved something akin to that, not identical, but akin in APL. And I actually, when I wrote my compiler, I tried to go full formal on it. I tried to actually have a real type system that did something useful on it. And so the problem with this is partly I was working in the array domain, which is a research area in terms of types. But the other part of this problem was that when I started writing the types, I had the choice of writing useless types that were so obvious they didn't matter, or the types that actually did say something that did matter were literally 5 to 10 times longer than the line of APL I was trying to type. And so at that point,
It is APL.
yeah, it's APL. So I actually think that types have been demonstrated. There's like some limited usability research that have demonstrated that types are very useful. But the reason they're useful is inside a specific context, it helps to address a specific usability problem in a given language. So if you change that context to where that usability disappears in some other way, now that type system doesn't become very usable. So what you can imagine is if the Haskellers continue to do even better, and they get more and more stuff expressive in their type system, they maybe go full dependent, and suddenly the dependent type system becomes expressive enough to automatically write all your terms for you. Well, you've got a really powerful untyped programming language at that point. And then you just don't, now you need to build tooling, debugging, and everything, and then at some point somebody's going to say, oh, you know, we should probably type this. And then it'll repeat, because you're addressing a particular problem using a particular mitigation technique. And it's a useful mitigation technique, it works, but we should not do that local optimization and sort of worship at the altar of types. We should think about what the end experience, the usability questions are, and find ways of achieving that as efficiently as possible and holistically, rather than just trying to invent the best type system. Yeah.
I will make a strange point. Remember the times where most of us didn't even exist, 70s, for example. There was, yeah. Thank you. Yeah. Yeah. There was situation when we had different assemblers for different architectures, and someone invented a C language. Oh, we know who did it, and in those language you could define some integer variables, and you could not even bother how these integer variables will be placed into the registers. This was clearly a step ahead, the untyped way of how does assembler do it. Nowadays we have a similar situation, but our registers not about real hardware registers. Our registers about processor scores and even human minds. To handle complexity we currently facing nowadays, we need to define our programs in such a way that the most of the stuff should be somehow visible to us, to not to get into details of this because it's a lot of programs, it's a lot of code, and without clear understanding of what's happening there, we have to go into the some tool to check this particular part, how it behaves, how it should be implemented in a certain way. Types help us to not leave our abstraction level in which we can solve these complex type problems. So yeah.
Yeah, just a bit more seriously about why I use types. There exist programming problems that I solve quite regularly where I have not internalized the answer fully. I don't know what it is I'm going to do. But if I can work out the type of what it is I'm going to do and then say to myself, if I can get a program with this type, I will have the solution. I use types to get me there. Then I also have to consider that I work with other people, it's not just myself, who have different things internalized. Like, consider, for example, I know the map function on lists, it's internalized in my head, and I don't really need the types. But there might be someone else who doesn't have that, and therefore we should use types for that as well. That's the real reason I use types.
Just to comment on that, there are also lots of cases where you know a term does what you want, but you have no idea what the type means. And those cases also exist in Haskell quite regularly. So I would say it goes both ways, right?
And I've given rants about type classes, right? So the focus there is that they write a significant cross-section of my code. That was the other piece that I wanted to say.
So I in fact have an active example of a language which is seriously considering rolling back its type system, and the answer is the LLVM language, right? So for those of the LLVM language, so for those of you who don't know, like essentially LLVM is sort of like a general abstraction over assembly language, so that different compilers can generate LLVM, and then LLVM can target different processors. And for those of you who use LLVM, or okay, even if you don't, so essentially LLVM actually tracks the type of many different pointers and of many different values. So within LLVM, it understands the notion of an integer of 32 bits, a floating point number, a character array of 32 elements and things like that. But then if you ever read C code or assembly code that's written by people, they don't give a shit, right? Like essentially so people who write C, you very often typecast between so within production C code, people often typecast things of the same size, right? There are lots of tricks that involve taking a pointer of one type, typecasting it to another type, and doing something to it. Or for example, taking a floating point number, sticking it into a union, pulling its integer representation out, and doing something with it. So essentially, encoding all of this within LLVM's type system just added a whole bunch of noise into LLVM. It made analyzing the language harder for no clear benefit anyway. Because the thing is, when LLVM eventually generates code, it doesn't really care about the type. It just cares about the memory widths. So within LLVM, there's been a serious discussion of essentially scaling back the type system to only, to essentially only track the sizes of objects in memory and not their semantic types at all. So I guess the moral of the story is a bad type system is worse than no type system at all, because right? Yeah, because